All right. Hey, everybody. Welcome to the Lightning Talks. I'm David Nicholson. I'm just going to give a really quick intro over the top. There's a couple things that are different this year. There's less going on. So we think that there might be more people. And like Corin said, the intro, also the conference keeps growing. And that's another reason we probably have more people here. And the other thing that is different for this year at the Lightning Talks is that for as long as anyone can remember, they've been hosted by Anthony Skopatz and Paul Ivanoff, who usually crack a bunch of really terrible puns between all the talks, except for last year when they asked the speakers to do it, which was possibly even more painful. So Lightning Talks, as you might already know, are just a chance to talk about a project that you're working on or anything else. It's a space to make sure that everybody has a chance to get up and talk. And we put the sign-up sheet link there. It's in the announcements. Jill put it there, and then we put it in the welcome as well. So please sign up there. If this is your first time speaking, or if you're from an underrepresented group, please note that next to your name, like we wrote in that post, so that way we can make sure to include you. So with that, we're going to jump into it. I'm David Nicholson, and I'll introduce myself more in a second, but I want to also thank the co-hosts that are here with me, and I'll let them introduce themselves, starting with Julie.
Hello, I'm Julie Halleck, and I manage a data science team at Mozilla, and this is my billionth SciPy conference.
Hi, I'm Madikan Monk. I am a postdoc at the University of Illinois. This is actually my third SciPy, which is really wild. I'm happy to be here and make amazing puns or terrible puns or whatever is going to happen.
A little of both, at least so far. And yeah, so they're both SciPy veterans, so very happy to have them here helping me. And again, since we thought we might have some newbies, we figured we'd do a very quick, what is a lightning talk, taking as little time as possible away from people that are actually going to get up and give talks. So I'm gonna drop a link in the chat here. This is from Tracy Teal, who was with the Carpentries and now is executive director at Dryad. And so this is from SciPy 2017. She gave this lightning talk guidelines. And now I'm going to try to give a fake lightning talk to explain what a lightning talk is, if I can figure out how to share my screen. Let's see what happens if I do that. Whoa.
Whoa!
Yeah.
Can you all see that?
Yes.
Yes.
Okay. I'm going to give a fake lightning talk. But let me actually go into presentation mode.
Ooh, whoa.
Okay. Yeah, so this is based on Tracy Teal's this is based on Tracy Teal's lightning talk guide. I'm going to talk about an imaginary project that I'm working on called Pyvonaut. Sorry, it's a funny pun, and it's going to get worse. What is Pyvonaut? But who am I? Why doesn't my computer like me? I'm David Nicholson. I am a machine learning engineer, which means I maintain the Learning Lake at Embedded Intelligence at a startup. The Learning Lake thing was a joke. Thank you. I'm one of these two people. Let me explain what I mean by that. Since the dawn of time, really, there's been a question of whether there's a real difference between Paul Ivanoff and David Nicholson. So that's why I've created this package, Pyvonaut, that creates a 12.7 billion row, 448 column open data set, updated in real time. Even before the term scientist had been defined, medieval scholars, for example, had created images to try to capture this idea, this question: is there a difference between Paul and David? This is from a group, of course, known as the Apostles. The deacon wrote that pun. The Apostles. Of course, we can look at this with some categorical data. Here's a table showing Paul Ivanov and David Nicholson. Differences and similarities, there are none as far as we can tell. Of course, now we're in an age of big data, so we can scrape the internet. If you Google David Nicholson, you'll find out that I'm either a whiskey or a soccer coach in Britain. So that's why we need to use the power and flexibility of the Python data science stack to provide insight into this question that's troubled humanity since time immemorial. That's Pythonot. So it's built on the cookie cutter that we developed for the PyOpenSci project. It follows the best practices established in our dev guide. And what it does is it scrapes the web for the latest Paul Ivanov and David Nicholson data using requests, Beautiful Soup, and Luigi. And then it builds and serves the Pythonov open dataset as a table with billions of rows using Dask and dataset inspired by a blog post that I forgot to include the link from in good lightning talk form. And once it's done, we of course will finally be able to use all of the modern data science tools to figure out if there is a difference between Paul Ivanov and David Nicholson. I'm really sorry to Katie Bowman for who actually made an incredible discovery, and I put Paul Ivanov's face in there instead.
Paul wasn't the incredible discovery.
Right. Yeah, and so if you go to my GitHub, you can check out Pythonauts, this project that I'm working on, except that it's not a real project, so you should not go check it out. But this, I hope, illustrated all of the things that you want to have in your talk: the who, what, then, where, and how, as Tracy Teal outlined in that post she's got that would link to. So thanks everybody for letting me stumble through that. Those were all the puns that I wrote this year for the lightning talk. So it's downhill from here. Sorry.
And like all good science, you still gave credit to everybody that was due. So, you know.
Thank you, Katie Bowman, for helping out. Okay.
Yes, so good.
So now I will attempt to stop sharing my screen, and we'll switch into actually giving other people a chance to come up and present what they actually want to share. And the first person that will be doing that is Tetsuo Komura, who I think is going to talk about a project, GetFem. Let me find him. And that means, Deacon, I'm going to let you drop
I'm out fast now.
Yeah.
Hi, everybody.
But thank you for vamping amazingly. In the meantime,
I'm here to hype everybody. Get ready.
You are.
Hype machine. I'm an air horn. Da-da-da-da.
My name is Tetsuo Koyama, and I'll talking about the translation project of Mayabit's Sphinx document. And first of all, I'm talking about me. My name is Tetsuo Koyama, and my ID of GitHub and Twitter is tkoyama010. And I always using this icon. Please remember this, not my face. And I'm a software engineer of science and engineering. And I'm a specialist of the finite element method. And my main contribution for OSS is GetFM and Mayabit. And I also in a translating team of Sphinx document of the Python. And maybe you know about Mayabit. Mayabit is a 3D scientific data visualization and plotting in Python. And you can show the VTK file using this. And it is a great library. And the concept of this project is translating this document to my local language, Japanese. And I used the same way with the Sphinx project documentation project page. in the Sphinx documentation project page, we can see the English Sphinx document and Portuguese in Brazil document and Japanese document and etc. And I want to do the same things in the MayaBeads document. In the Sphinx doc translation, they use the GitHub CI to translate the document. First of all, they have the English documentation for Sphinx is updated, and then the corresponding translation file is updated by using the GitHub CI and uploaded it to the translation file to the Transfix site, and by using the Transfix, which is a translation site, we translated it to the local language like Japanese and Chinese or Portuguese and etc. After all, the translated translation file is downloaded and uploaded to the home page. And in this project, I did the same things in the MayaBee project and make the Transfix repository to translate. When you want to translate the MayaBeads documentation page, you can use these steps to translate the document. First, please log into the translation Transfix service and go to MayaBee translation page. And please click the request language you want to translate. So maybe your native language and your language you want to translate to. And wait acceptance by the Transfix MayaBee translation maintenance, and after that, translate on Transfix. After all, you can see the translated page at the read the docs page, and that is a way to translate the document. And this is the Transfix page for MayaBeads document. Sphinx can pick up the sentences which you should translate and can upload to the Transfix. And all you have to do is translate the sentences for each cells, and you can make the translated pages like this. If you are interested in translated document of MayaBeads, please contact me and translate and share it in your locals. And that's all. Thank you.
Thank you, Tetsuo. With like a minute left, nice. It looks like a very cool project. It's definitely a great way to give people access by translating the docs to different languages. So thank you.
Okay, I'm going to talk about Testbook. So Testbook is a library that helps you unit test your Jupyter notebooks. I'm sure all of you have interacted with Jupyter notebooks, and I hope all of you have come across unit testing as a software workflow. So we aim to make unit testing Jupyter notebooks easier. So I'll talk a little bit more about that. So about me, my name is Rohit Sanjay. I'm from India, and I am a final year electronics engineering student. And I am also a participant in this year's Google Summer of Code. And that's where I'm working on Testbook. It's a new project. We built it from scratch. And under the mentorship of Matthew Seal, He goes on Twitter by @CodeSteel. And I love Python and C, and these are my links, github.com/RohitSanj. And you can find me on Twitter at I'm RohitSanj, and this is my personal website. All of the three are different. I can't help it. All right. So let's get into a little bit more about the context behind why Testbook was created. First of all, Jupyter Notebooks, they're going beyond just a tool for experimentation. I mean, we're seeing it in multiple production workflows and production environments nowadays. And the team at Netflix is a testament to this. I mean, the team at Netflix are doing great things for productionizing Jupyter Notebooks. And keeping that in mind, and also Jupyter Notebooks can get very messy. If you have ever worked on a data science project, you know that code is just sprung about and there's not much structure to the code. So enforcing good habits can make it maintainable. So some of these good habits are, you can use functions to abstract away the complexity, and you can smuggle code out of the Jupyter Notebooks. You can apply test-driven development, and you can make small and frequent commits, right? So what I want to focus on here is the test-driven development part. So there's two ways to do that. You could either write the tests in the notebook itself, or you could refactor the code out of the notebooks and write them in separate Python modules that can be independently unit tested. And the workflow for refactoring this is, I found this off of a blog post online written by a person named David Tan. So he lists these steps. I mean, I don't mean to throw shade or anything, but it just looks a little too, it looks like a little too much work. I mean, you have to make a copy of the notebook, you have to convert it as a Python file, remove print statements, list code smells, and then finally we get to the unit tests, right? So we got to do this crazy amount of setup work and refactoring before you can actually write the unit tests. So this is where Testbook comes in, and where you can write your unit tests directly for the Jupyter Notebooks, and without having to refactor the code out of it, and hence it can help you write maintainable and reliable Jupyter Notebooks, right? So these are just the features. I'm just going to go over them real quick. You can write conventional unit tests for Jupyter Notebooks, as I said, and you can execute all or some specific cells before a particular unit test, and you can even share kernel context across multiple tests, inject code, and the main thing that Testbook strives to be is to be like a plugin to all the existing libraries, so that you don't have to solely use Testbook to unit test. You can use it with PyTest, unit test, or Nose, or any other. Please, there is an issue if it doesn't work with your preferred choice of unit testing library. So this is a simple unit test using Testbook. So you have a function func in a Jupyter Notebook, and this is in a Python module. So you just there's some boilerplate to say that this is the notebook I want to test, and execute it before you run this test. And this func just says, give me a reference to this func, something called func in the notebook, and then call func of 1, 2 equal to 3. So the idea that we had in mind is that it should look like a real test, but just that it's running on a notebook, but you wouldn't know that, right? And this is a slightly more complicated example where there's a foo class, and you get a reference to that class first, and then you use it as you would like if you had it in another in the same Python file, right? And so that was my time. I think I have 3 seconds left according to my clock. But these are the links. You can go ahead and do pip install interact-testbook. And we're on GitHub at /interact/testbook. Drop a star for good karma. And this is the docs link. So that was my time.
Great. Thanks, Rohit. Sounds like an awesome project.
So first off, I'd like to thank the conference organizers for organizing such a wonderful virtual event, as well as to the hosts for organizing this lightning talk. So I'm Sean Law. You can follow me on Twitter at SeanMyLaw. You can also follow the development of SciPy, which is a basically modern time series analysis. So just to getting right into it, a little bit of background. I'm also one of the co-organizers of PyData Ann Arbor, so check us out. We've got a lot of our YouTube videos posted. Data science. I'm also a senior research scientist and data scientist at TD Ameritrade, and I work in a team called the Exploration Lab. So it's an R&D group, and that's actually where SciPy was born. And I'll get right into the a live demo here. So I'm sure that a lot of the folks that are on this lightning talk right now have dealt with time series data where maybe it's a new data set or somebody kind of showed it to you and you've never seen it before. So I'm going to draw your attention to this time series up at the very top here. Can anybody spot anything interesting about it? Any patterns, any anomalies, any insights? Typical sort of exploratory data analysis. And not to belabor the point, right? But the idea here is that it's actually very, very hard. Even if you visualize it, you can use traditional methods or even deep learning methods to try to look for things. But the problem there is that oftentimes you need a lot of expertise, or it's highly uninterpretable. With what we're doing here with SciPy, we're providing a way for you to do some of that exploratory data analysis. So given this time series, if I showed you this subsequence within a time series, and I've zoomed in on green, and it's shown in green here, zoomed in. If I told you that this subsequence repeats itself once along this time series, can you spot it? Again, it's very, very hard to do that. Even if I showed it to you, it's actually all the way at the other end in gray, and I've overlaid the green curve and the gray curve. And you can see that they roughly match. For all intents and purposes, they're pretty good. And the distance between them, if we calculate the z-normalized Euclidean distance, is about a 5.5. And it's not 0, right? Because there are differences near the end here and near the beginning. But again, they're pretty close. But the point is that if you were to try to find a match for this green pattern, you'd have to basically keep the green pattern still and slide this gray box across the entire time series. And then calculate all these pairwise Euclidean distances. And then if you didn't even know if there was a pattern for you to look for, you'd have to also slide the green box across too. With SciPy, it does this for you in a highly optimized and efficient manner. And so when I press play here, you'll see that the green box slides across and the closest match to it starts appearing. And you can also see that the distances also change too. Another thing to notice too is that your closest match doesn't have to come afterwards. It can also come in history. So if you're thinking about analyzing time series data, SciPy allows you to identify immediately what the closest matches are, but almost as a freebie, you also get essentially potential anomalies too. So if I scroll back here, you'll see that this particular point, this is what is called the matrix profile. And what it gives you is basically the distance to your nearest neighbor. And for this particular case, this green line, its closest neighbor is 23 units away. And you can see that this gray line really just doesn't match it. So getting back to the point here, with the matrix profile, really this is the tip of the iceberg. You can not only find patterns and anomalies, but you can also do things such as finding time series chains. If you have multiple time series that you're collecting, let's say from IoT sensors, you can actually do multidimensional matrix profile analyses. You can also look for change point or switch point analysis using semantic segmentation. You can even do perform time series clustering or even snippets and much, much more. And because we're at SciPy, there's really what's really great about SciPy is that there are very, very few dependencies. In addition to supporting Python 3.6 plus, it only depends on NumPy, Numba, and SciPy, and that's it, nothing else. And we have GPU support thanks to Numba. Last but not least, if you're looking for us in your favorite search engine, just search for Python SciPy. If you're looking for tutorials, we have very elaborate full-form tutorials. Go to tiny.cc SciPy tutorials. And if you want to play with a demo that I just showed you a moment ago, go to tiny.cc SciPy demo. And for a GitHub repo, you can find that at tiny.cc SciPy code. And then for all of our APIs and docs, you can go to tiny.cc SciPy docs. And again, follow us on Twitter at SeanMyLaw or again, SciPy Dev. With that, I'd like to hand it back to our great hosts. Thank you so much.
Thank you, Sean.
So you're saying that the trunk of SciPy is the SciPy stack?
Yes, exactly. There you go. I tried to find a cheese and stump picture, but I couldn't find one.
Trees and cheese don't mix so well. Celia, I think, is next.
Yeah, Celia is up next. Thank you again, Sean.
Thank you.
Yeah. Thank you for being here.
Yeah, super. Can you see my screen?
Yeah.
Awesome. So hello, everyone. My name is Celia, and along with Melissa Mendoza, we work on the Diversity and Inclusion Committee at SciPy. We wanted to share the diversity numbers of the conference from 2017 till this year. So the numbers that we're going to share today come from two different sources. First, we have the registration survey that contains diversity questions. These are optional during the registration process. Across all years, close to 80% of the participants completed these questions. Also, this year, we included the reviewer guidelines survey to revise their usefulness and possible improvements for reviewers and chairs. Just to give a quick overview of the geography of each year, we can see an increase on the different countries joining the event from 2017 with 11 countries to this year that we have 57 countries at SciPy. So on this update, we look at three angles of the diversity spectrum: gender, age, and ethnicity. Regarding gender, we can see an increase of attendees that identify themselves as women of the total of participants. But it also shows non-binary third gender attendance is low, and we need to work more closely with LGBTQ+ communities to see how we can make SciPy more welcoming and inclusive to underrepresented genders. Now, regarding age groups, we can see that in each year we're getting a more diverse range of ages, particularly increasing participation of people between 51 and 64 years old and 65 years old plus. And also this year we have also younger attendees under 21 years old. At present, a large percentage of participation are white. For this year, is 46% of the attendees. Currently, only 3% of our participants are Black African Americans, 1% for Native Americans, 1% for North Africans and Middle Easterns, and 6% for Hispanic and Latinos. The SciPy meeting has not had the same level of focused outreach to the Black community and other underrepresented groups. But we want to change this for next year. So we're doing our first next steps. We will dedicate 50% of our scholarship budget to support attendance of Black, Indigenous, and people of color to SciPy meetings. We will actively seek for experts from these communities to speak at keynotes, tutorials, and talks, and we will encourage a more diverse participation in SciPy planning committees. These are some of the first steps that we're taking, but you can look at the online statement for the full list. Now, let's get to the reviewer side of life. So this year, we asked them if they identify as a member of an underrepresented group. 44% of them replied yes, so yay. We can see that we have a very diverse set of reviewers looking at SciPy proposals on 2020. And lastly, back in 2017, the SciPy program and diversity committee added a reviewer guidelines that were shared with all programs committee members. In these guidelines, we added some cases of unconscious bias examples, and we wanted to know if they were helpful to the reviewers. 77% of the reviewers answered that the guidelines help raise awareness of unconscious bias during the review process. Thank you everyone for your time. If you have any ideas on how can we improve diversity at SciPy, please send us an email, or if you want to know about other activities that we're doing, please join the Slack channel that Melissa created today. Thank you very much.
Thank you so much, Celia. And thank you for staying awake this late.
Yeah, thank you. This is like really important work. And one thing I will say, having been in the SciPy community for a while now, is that it's really exciting to see how open and to change that this community is. And given like how data are being used everywhere, it's really important that we remain diverse and inclusive. I have no puns.
Sure.
Adam is up next.
Yeah, I will find Adam.
Perfect. So this is my first SciPy, so I wasn't sure what to expect for the lightning talks, and it seems like everyone was so much more well prepared than I was. So I'm just going to dive into it. My name's Tyson. Like I said, this is my first time here. During the day, I am the instrument operations manager for a Department of Energy user facility, working out of the Chicago area. But in my free time, when I get it at work and outside of work, I like to code, a little soothing for the soul. But I work with a lot of data from atmospheric instrumentation, time series data by n-dimensional type of data sets. So anything from soil moisture, air temperature, cloud cover, lidars. That's really where the focus area is for me. And really, in looking across the atmospheric science community, the programs that we interact with on a regular basis, we saw that there's a lot of redundant coding going on across the community. I mean, even if you look at the universities, I mean, how many times do grad students have to write code to read data and create visualizations? I know it's a rite of passage, but there's a lot of redundancy there too. So we also saw that the norm was sharing data and not code. So you had issues with transparency. And having to trust that what was coded up was actually what you were being told was in there. So, and we also saw that depending on whose code you got, that constants weren't necessarily constant between codes. So we had a great team from Argonne National Lab, from the University of Oklahoma, and Oak Ridge National Lab that started working on and contributing to an open source Python-based community toolkit. Geared towards kind of affecting change in these problem areas that we saw. So we were looking to reduce the duplication of effort, enable easier sharing of code across the groups, and ensure consistency in some of these codes as well. And of course, create transparency in how things were being done by having it open source. So that's really how the Atmospheric Data Community Toolkit was developed. It's a Python library, like I said, for working with atmospheric time series data. It's built off of Xarray, uses Sphinx for the documentation, Travis CI for the unit testing and continuous integration. We recently added coveralls and Zenodo for co-coverage and DOI generation. We continue to kind of try and grow this. Right now, it has a lot of different modules, anything from data discovery to IO to visualizations, quality control. There's different corrections, retrievals, general utilities, but we're trying to get something that can work across programs. So not just in the program I have, but or that I'm a part of, but there's programs all over the world that use the same sort of instrumentation that we deploy. So if we can get everyone kind of working on the same code set, we move hundreds of singular codes and people working on those codes to one code set with 100 people working on it, which no doubt will lead to better code and more productive science, really. So and in in looking at open source and trying to work with others, we recently made a bridge. So we are working and have tools to interact with the Python ARM radar toolkit, which is a big Python library for working with radar data, weather radar data, which was great to see. And I won't go through any of that other stuff there, but this is just examples of plots that we're producing from various data sets, using Xarray object as our base to pass around between all these different modules. So I'll keep this short and sweet. Really going forward, we want to grow the user base and the contributors, improve our code coverage, but then most importantly, we want to build up the modules, get people to contribute back, especially in the retrievals, the corrections, the quality control for those in the atmospheric science community that are interested. And of course, it's all open. We're updating the roadmap every 6 months on GitHub, and pip and conda installable. So if you have any questions, let me know. But otherwise, I'll hand it back over.
Great, Adam. I don't know. You seem pretty, yeah, you seem pretty prepared.
Yeah, I don't know what you're talking about. Everybody else is more prepared. You should see the chaos that is my computer all the time.
I mean, obviously, I was more prepared for my talk, but no, that was great, and it's great to see the community coming together. So thanks for telling us.
Thank you.
Talk.
Yes.
I'm looking forward to tomorrow.
Me as well.
Anybody who's interested, you can obviously you can prepare ahead of time, or you can do something a little more on the fly.
Yeah.
Seems like there's a wide array of topics you can present on. Obviously, none of us can quite use an amazing machine learning algorithm to compare ourselves to Paul Ivanov, but
I mean, what I'm really interested in is the fluid dynamics of nacho cheese fountains. So
yes.
on that, where I mean, it was just an inside joke between you and Julie, but I really want one now.
So any of you who want ideas, we have some amazing Lightning Talk ideas happening in the Lightning Talks channel. Julie and I have proposed that there should be a queso fountain centerpiece at SciPy every year. Obviously, since we're not in person, it's in the center of our minds instead. And
we're responding to you right now.
it's only you if people don't follow hygiene practices. But it would be amazing. Imagine just the centerpiece of cheese, liquid cheese.
Yeah.
You can dip everything in. It's great.
I think we should do like some computational modeling in a notebook first, and then we'll see how it goes.
Yeah. So we have some great suggestions going in the Lightning Talk channel. You can feel free to add other cool ideas. I mean, obviously, I would like to see some catter plots happening, cat analysis. David, is there anything you really want to see in the Lightning Talks? Anything
I am pro catter plots. I cannot give my own. And I should not give any more Lightning Talks this time. So we need other people definitely to contribute.
Yes.
Catter plots using IPy volume or whatever tool is easiest for you to work with your cat data.
Yes.
Right. Or dog data,
Yes, cat or dog or bird data. I mean, obviously bird identification, big deal. Very cool.
Yeah, Gil Forsyth, I think, is working on a burb algorithm.
I heard the bird is the word.
Yeah.
So
I was about to start singing that, but I feel like we should stop vamping and sign out of the Lightning Talks.
Yes.
Thanks everyone for participating and being really patient with us while we worked out the kinks.
We're leaving you all on a high note. The highest of high notes. Yeah.
and all the talks so far have been really great. So
yes, you've all been amazing. We're really happy for your participation, and get ready for Lightning Talks tomorrow.
Yeah, round 2.
Just gonna storm it up.
For sure. I might go on strike for a Lightning Talk. So lightning strike.
Wow.
All right, we need to end it now. We gotta end the talk.
Okay, bye everybody.
Bye.